next speaker is Brian Fisher. Brian is Associate Professor at Simon Fraser University in the School of Interactive Arts and Technology and the program in Cognitive Science, and he's Director of the Science Lab, an acronym for the thing at the bottom there, and a member of the VAR Lab. His research aims are to advance new theories and research methods for understanding how highly interactive visual information systems can support close coupling of human and computational processes for improved performance in cognitive tasks, such as situation analysis, decision-making, creativity, and collaboration in situations ranging from emergency management to aircraft safety, computer-aided design, security administration, and computer-supported learning. He will talk to us this afternoon about visual analytics and cognitive science.
Right. Excellent, thank you. So I apologize for the picture of the brain. My students did that in giving the lab acronym some kind of, it's not as great a sin as doing connections though, so I might take after that. And the bridge, I've given a talk on bridges at IEEE, and that's the bridge from Tampa to Sarasota, I believe. A part of our laboratory experience. And so I made a small change to my title, Visual Analytics versus Cognitive Science. I'm going to talk a little bit about my double life. And the take-home message is it's mostly Zenon's fault. So I came into this world of the University of Western Ontario, having just graduated with a PhD in psychology from the University of California at Santa Cruz. And for a psychologist, I'd been a programmer in the Valley, so I could code, which was rare among psychologists in the day. And I was reasonably good at math, so I did a modeling dissertation. As part of my introduction to psychology, it started when I, having never had a psych course, had to take the Contemporary Issues graduate course. And in the course, we did the imagery debate. And so they sent us off with a Polishin and a Koslin paper, and we were supposed to read these and come back. And I came back completely convinced that Zenon was correct, to discover I was the only person in the entire seminar who thought that way. And so that was the foreshadowing of what was about to happen. I finished my PhD, and I got 3 job offers. One in Boca Raton, Florida, at the Center for Complex Systems. Very nice, going from California to Florida. I could keep the beach. The other was at NASA Ames, where I had another beach, technology, sun and ocean. And the third was a postdoc in London, Ontario, with Zen Polishin, where I had hockey, snow, and Lake Huron. So clearly, I had a decision to make, so I talked to a senior guy in my group, and he said, I think it's almost a direct quote, "I disagree with everything he stands for, but you will learn more from Polishin than you would at the other places." So this was some fellow who had a completely different perspective, but he figured that Zenon would teach me a great deal. So at that point, I moved to University of Western Ontario for a postdoc, working with Zenon's group. And Zenon's group turned out to be quite interesting because there were all of these computer scientists and engineers and all of these psychologists put into the same laboratory, and we had these great discussions, and we had a lot of parties. At one fateful party at Zenon's house, I ended up sitting on the floor with a visitor from Simon Fraser University, grad student, with a bottle of wine between us and a couple of glasses. Zenon had famous parties at Western. And through it, we thought, wouldn't it be great if we could take this kind of Zenon model of engineering versus, or in collaboration with cognitive science, and supersize it. I mean, let's build a big grant in the new Network of Centers of Excellence proposal and see whether this could possibly get accepted. So we did. Meanwhile, I'd gone to Ruckus, this was, or Rux, I guess, as a visiting faculty member for a year. And that's how I know many of you. And then, you know, through some strange error in the reviewing process, this grant actually got funded, which I think was a product of the fact it had every buzzword available at the time in the title. And so a cognitive basis for the the design of intelligent interfaces to complex systems. And my job was to move back and forth between the University of Western Ontario, where Zen's group still was, and this computer science group that was at SFU and UBC. And I was supposed to, bring, cognitive science to the computer scientists mostly, and to try to get the computer scientists to work on interesting projects. So I was kind of a shuttle diplomat. We were basically trying to take the collision lab, then it had come to Rutgers, and we were trying to take it, not quite coast to coast, but more than halfway across. Now, I'd already known about human-computer interaction, and when I took my human-computer interaction course, it was explained to me that, well, this is kind of an applied psychology. You do the psychology research, and it's pure research, it's basic research, and then these people building interfaces will come in, and they'll look at that generalizable, fundamental research, and they'll focus it on some little application. And it's, if any theories are generated, they're pretty small theories. It's really kind of tied to that particular implementation. It's a good career prospect, but psychologists don't really care about HCI. I mean, it's really, it's a nice place that students get jobs. Anyway, through this process of thinking about working with Zen and UWO, I began to realize that there was some mirroring between human cognition and computation that was a bit deeper than I think HCI of the day gave credit for. And I got interested in technologies whose fundamental goals are to interact with human cognition for some end. So air traffic control, you can talk about usability of air traffic control system, but an air traffic control system fundamentally just lets air traffic controllers know what's going on out there. And so the utility of the system really is between the ears of the air traffic controller to a large extent. And so it's not just usability, it's the basic core raison d'etre for the whole technology. Same with educational technology for learning, social computing, decision support systems, and so on. And so this sort of took HCI at a new level. And I had this belief that some of this application-driven basic research could be created. We could look at those things as fundamental questions about how people see and how they collaborate, and we could advance as psychological science. Now, at that point, I was ruined for psychology. So having come in 3 years later as an experimental psychologist, I was now this interdisciplinary guy. And so this part is my fault, but I view it as a continuation of Zenon's fault, so I'm still ascribing much to blame to him. I took a job as the associate director of the UBC Media and Graphics Interdisciplinary Center, where I just cranked out projects. I got an associate or adjunct position in business, psychology, and computer science, did a lot of work with industries. We created a bunch of companies, some of them got funded. ThoughtShare made me a millionaire before I realized that it was all on paper, and then it disappeared. But I still have the t-shirts. And we did some not-for-profits. New Ventures BC is a business plan competition. VARDEC is a visual analytics consortium, and some educational initiatives and so forth. Now this part, I say it's my fault, it's probably my spouse's fault, because I think she was the one who said, why don't you get a real job? So I was in this position of having, it's almost a postdoc for life, but with a real salary. Magic was wonderful, because it gave me a faculty salary, and all I got to do was research and teach when I felt like it. I didn't have to sit on any committees. It's still the pleasantest time of my life, but it wasn't a tenure-track position. So I bit the bullet and took a job at a new SFU School of Interactive Arts and Technology, where we combine all sorts of interesting things. And there I teach cognitive science, a lot of cognitive psychology to artists, designers, and engineers, sort of cyber psychology, if you will. I still liked my old postdoc for life, so I kept it. I just took a leave from my salary. And so this is my hobby now. I spend a couple days a week at UBC. It also has a really nice lab, and I have a much nicer office, which keeps me coming back. So I'm in this position of trying to replicate the environment I had at UWO and to build some kind of a bridge between the engineering world, which I'm going to describe through IEEE, and much of my publications and a lot of my service to the field comes through the IEEE visualization, graphics, technical committee. I'm on their steering committee and the executive committee for the visualization group. And so I spent a lot of time there. And they have the ability to write code. They just love writing code. They can generate some really nice grants. And I believe they have some amazing basic research questions that fall out of what people experience in these environments. That's different from what they experience in face-to-face environment. And some fundamental questions can come from that. Cognitive science or cognitive psychology has some great methods. Computer scientists doing HCI don't have as elegant or as rigorous methodologies as experimental psychologists, by and large. They have a whole bunch of theories, and they read books, so they actually know their theories. They have phenomena that people can explore. That's where many of the basic research questions come. And they have people who just love running studies. They have graduate students who will go into the lab, I don't know whether they love it, but they do it, and run thousands of trials and dozens of subjects. And so there's this lovely simpatico. And the only thing between this massive success in technology and psychology is this small matter of defining your boundary objects. What are you talking about? Clashes in culture, finding publication venues, finding academic jobs for the students, especially some of the sort of psychology, cognitive science students, come out looking like a computer scientist to the psychologist and looking like a psychologist to the computer scientist. So this is my lab mascot, and it's where we try to take things, is we find a way that we can do something that is, scientific. Well, at this point, I got approached by a group of people that had gotten charter from the U.S. Department of Homeland Security. This was about 2003 or 4. There was the belief that the systems we were using for decision support were failing us. We were putting too much into the technology. Human analysts were not able to see everything they needed to see, and that's one of the reasons we missed 9/11. It's also one of the reasons later that we're not as successful at dealing with Katrina as we might have been. So there was the belief that the computer systems were not helping us. We needed to step back and take a more science-based approach. And so this group of people got together at the Battelle's Pacific Northwest National Lab and came up with this new field, a new interdisciplinary field, visual analytics, defined as the science of analytical reasoning facilitated by interactive visual interfaces. So this really is a cyber psychology or a cyber cognitive science. It is a science. It focuses on reasoning. It doesn't focus on the technology. But it focuses reasoning as it's facilitated by the technology. And they have grandiose claims. It's a grand challenge document. They wanted to get millions of dollars thrown at it by DHS and other people. And it's in an IEEE book, press book. And it started a bunch of things. There's a big coordination action in Europe and a strategic priority program in Germany, so it's gone somewhere. So at this point, I got involved in IEEE Viz. And what I see in Viz is what you often find in the HCI world, but it's more of a problem because all of the applications of visualization, their goal is they take place between people's ears. So a visualization system is only useful if people can see the pattern, can make the decisions, can interact with them, and produce the right decision. There are a lot of designs that are based on theories, but they have no way of going back and testing the validity of that. They adapt methods from the cognitive science, but they haven't done as much reading. After all, they have doctorates or are getting doctorates in computer science. One can't expect them to get a parallel doctorate in psychology. And the thing that amazes me is there seems to be a real challenge in collaborating with cognitive scientists. I always say that, in all of these computer science departments, you can look out the office window and you'll see other buildings on your campus. And in those buildings, there are people who know a lot more social sciences, a lot more cognitive science, a lot more perceptual science than you do. And you can cross at the light, it's entirely safe, and you can find those people. And so in my lab, we look at how people see and think with interactive visualizations. We try to take it back to cognitive models. We look at customization of those models, parameterizing a model. It might be a mathematical model, or it might be a computational model, based on that individual's personal equation, their individual capabilities, so that can capture natural predilections It can also capture training and perceptual expertise and so on. So we don't want to work for the generals. We would like to take it to take a general model and customize it for a specific set of users. And we focus on the reasoning techniques, presentation, argumentation, and so on. And those methods are more qualitative, cognitive ethnography, lab and field experiments, and so on. So as it's evolved, I've moved away from the bridging from one side, and we're sort of trying to set up this little island in the middle, and we're operating on faith that at some point these are all going to connect. It's not going to go like this, and we don't know if that's entirely true. I find that the psychology research gets a lot of traction at Viz. They don't necessarily want to do it, but if you package it and present it correctly, that community is very welcoming. Psychologists are not so interested in what's going on over there in IEEE. That's me, at my lab. So I'll talk about a couple of experiments just briefly. It's a general high-level talk. In here you'll see cognitive architecture and FINS. So that stuff is part and parcel of what we're doing. The great thing about cognitive architecture is you can take it to the bank. It will hold true for experts. It will hold true for novices. You might have to parameterize it a bit to deal with expertise, but you're not going to grow a new cone pigment no matter how hard you try. So it's nice and solid. And if it's true, and I believe it is, it ought to be good for something. And we can try to show how it's good for something. We do some FINS work. For some of the grounding work, we look at social cognition. We do some nice psycholinguistic discourse analysis. Clark's joint activity theory, we do a bit of grounded theory. And all of that stuff takes place in the context of emergency operations, and those are grant funding agencies and companies underneath. Vaccine is the DHS Center of Excellence in Command Control and Interoperability, and serves our NSF. Air traffic control, Hughes Raytheon Labs, Boeing on aircraft safety, and so on. And we've managed to keep most of the publications are on the applied side because those just drop off the tree, but we kind of circle back and we get some psychology or cognitive science publications from time to time. I've bold-faced the personalized medicine, public health, because that's a big growing area for my lab. So I'm going to give a quick example or two, and then I will finish up. And here's a very FINSty example. It's an older study, but it's an easy study to describe. We started working with Hughes Raytheon Labs, and they were part of a big system with NASA and with a bunch of other companies to build the next-gen air traffic control system. So we want to move away from a plan view display, where it looks like you're looking down at a radar display. There aren't radars anymore. The planes are all tagged. I mean, there may be radars somewhere, but you could digitally process that. And you could create a display that looks different. Well, what display do we want? The tricky bit is that how do you validate an air traffic control display when the acceptable error rate is 0, unlike PowerPoint? So you need to have a way of testing it to exhaustion, a very strong test. One of the things that they wanted to do was to change the camera position so that controllers could get a different view. We said, hey, this looks like multiple object tracking, multiple aircraft tracking, and it looks like multiple aircraft tracking when the camera position changes. Well, that's actually kind of interesting. And so I started to talk to my colleague Jim Enns and say, why don't we do something about this using your students? So here is another multiple object tracking task. And this is one of the display shifts that we did. We tested the whole Lie algebra and all in combination. So there was a bunch of studies done on this. And you're asked to do the task. And of course, everyone here is a veteran of that. Do you think you can do it? Show of hands. Will this hurt her performance or not?
Yes.
Yes.
You can do it or it'll hurt performance?
Cannot do it.
Okay, there's a mix. Well, I thought it would kill performance and we could stop next-gen air traffic control. It didn't hurt performance at all. You recover the number of objects, you recover the scene speed, but the motion of the world through all of these Lie algebras was, or Lie transformations was, completely non-significant. So we think it's a pretty powerful study because we're getting effects of number and speed. But of course, as Brian Schill told us earlier, you have to break it first. to make sure that it works. Whoops. And so if you warp the space so that it's no longer, the space itself begins to sort of stretch and move a bit with the same kind of motions, then you do repetitive seed speed. So it's dependent on having space being static, well-formed. Even though that space moves, it can be tweaked. Another bit that we're doing that is more on the application end draws upon joint activity theory. So this is Herb Clark's work. And we've taken it first into musical performance to look at how people, the same model that shows how people communicate linguistically can be used to look at how musicians coordinate an ensemble playing. And that's Linda Castro's work. But it also can be used to look at how people collaborate on an analysis. So this is my student, Andy Wade, working with a Boeing safety analyst at Boeing Company, going through a bunch of Boeing data and FAA data, trying to build an understanding of what's going on. And then what we do is we capture this session. We use the joint activity theory framework as a lens to view it on, and we look at how people are communicating, the concepts they're using, how they're building common ground, how they gesture and use the screen. We do all of this analysis, grounded analysis of communication in that environment. So there's some really nice psycholinguistic stuff that come out of it, and we get stuff in like psychonomics. We haven't published it in journal form because it's still relatively new and we're still working on it. But it has a real impact on the company. So when Andy was there at Boeing, he changed the design of 5 aircraft. They only have 4 of them here. I don't recall what the 5th one was. And the changes to the pilot training manual. And that work got presented to a whole bunch of engineers, the aviation safety community, and so on. And so it had a big impact at Boeing, which was helpful in us getting more support from Boeing. And we've gotten quite a bit of support from Boeing. So this, to me, is the punchline, and this is what I think we should be doing in a more general sense. It is kind of a supersizing of what we did at UWO, I think. You've got this world of cognitive psychologists, you're cognitive scientists, you've got a whole bunch of graphical and interaction design folks that know a lot about graphic and interaction design. You've got these social sciences, qualitative methods, and then you've got the computation, and we do work with mixed analytics, mixed initiative systems with colleagues in computer science. And then you have this thing in the middle, which I'll call analysis in the wild. You know, this space where you actually look at how people are interacting with these systems. And research questions could come out of that can actually change these fields. Now, I think for that to happen, it's going to take some kind of a support in terms of, interdisciplinary centers. RUX is one, and and institutes and so on. So I'll open it up for questions. Another Arvo shot here. Yeah, it was an interesting study, and that pot of money finally ended, and we moved on to other things, and it's something I want to revisit. The hypothesis you would come into this, and the hypothesis I had was, look, you're tracking objects and they're moving around in a flat space. And retinal speed is the thing that's going to determine whether you can track them. And there's going to be other factors, like if they're near misses or they cross, and the stuff Brian showed where, if you link them, there's a lot of other factors. But the fundamental thing is retinal speed is going to be, like primary determinant, or at least really important. If there's not funny stuff happening in display, that is the important thing. And so that's the model we came into. And then you say, well, when they're building these displays, they're building them as fish tank VR. There's a question of whether it would be VR with stereo glasses, and that's been proposed, or VR, but that's hard to do for the hours in the air traffic controller. Or just perspective VR, so you're looking at a 3D space rendered in 2D, and so it would be, but in either case, you're going to have the camera motion. And so what we wanted to do was to experiment with the camera motions and find a way that, normally if you gave the camera motion with the thing zoomed or rotated, you would expect that it's going to change the retinal speed of the individual objects. So we wanted to push it against a specific change in the retinal speed. We just sped them up and to try to see whether the conjugate motion of a fish tank VR world is going to affect tracking behavior as if it was individual motion, average motion of the objects themselves. And there's a lot of stuff you can do to play with it, but what our expectation was that it would break, that motion would be, as soon as it exceeded your tracking capability, you wouldn't be able to track. And I even had the idea that it would probably break because the idea that they all move together seemed to me to be a really good way to lose a fence, just from having done fence. But this is why we do experiments. We were surprised to find we didn't get the effect, and we dwindled all sorts of variables. Jim has a lot of students. And we couldn't make that effect appear, but we could, speed them up, slow them down. We couldn't, we could make other effects appear. So we came up with this idea, and I've actually got a picture of it, of just taking our display and projecting it on a curved surface or an angled surface, and then you would get a certain motion of the objects, but the space itself was ill-formed, and that recovered the effect.
So you track in 3D, not in 2D. You can track in 3D just as well as in 2D.
It seems as if you can. Now again, this is the sort of thing that, and this is my translational bridge business. I don't want to get sucked into, because of the position I'm in not in the psych department, I can't get sucked into a long set of psychophysical experiments. What I want to do, and try to do, is to work with someone like Jim, who is quite happy to get sucked into a long set of psychophysical experiments. And so what I'd love to do is to have more studies along these lines done, collaborate on the stuff, but what I'd like to do is to get the first few studies and help to feed it into that community. I don't go to VSS much, but I've gone to psychonomics and I do I've gone to APS, but to try to get this stuff picked up. It would be nice to do more.
We did the one experiment, collaborative experiment between us and
we did the thing with Steve.
yeah, in which we pinned the question of what mattered is the speed or the density of objects, and you separate the two with this kind of display.
Yeah, well, we certainly, again, this is the interesting bit about the collaboration, and I think it's culture that stops it from happening most places. We've got a lot of stereo displays where I am. Not every psych department has them. And we've got students who would love to get master's theses coding these kinds of subjects. They don't, for a psychologist, I did a lot of coding for my PhD, and that was kind of off the books. That was something that, I had to do my empirical test. Nobody cared whether I wrote the code or bought the code or had no code. But for these guys, it's a master's. So this connection is a very nice one, I think. But, the thing that has made it work are things like magic, where there is someone who owns the collaborative process and helps to keep people in their comfort zones. That's a big part of what I did at Magic and try to do, at CN as well. But yeah, it'd be great to have better links to psychology. As a second choice, it would be great to have more PhD students from psychology backgrounds. But you have to get a PhD student who is willing to stick their neck out, go to a school of interactive arts and technology, and get a PhD in something that sounds very odd, and render themselves unemployable for psychology departments, potentially, by so doing. So it's a daring thing for them to do, and it's not easy to recruit. But it's more fun, I think, than, I could have gotten a job doing psychology in a psychology department, perhaps, and just done that work, but this really tickled my fancy, so. Even though I blame you for it, in the end, I'm enjoying it.
Could I ask a follow-on question, because I wasn't quite sure I understood the answer. So, the retinal motion will be a joint function of the motion within the frame established by the box and the motion of the box.
That's what I
Did
thought.
I understand you to say that it wasn't, it turned out the
The
retinal
motion of the
was
box
not what caused
doesn't
it
seem
fall?
to have an effect. Certainly not an effect that we could
So it's
measure.
speed within the frame of reference.
That's right.
Ah.
Yeah, that was an important finding. Should have continued on that.
Yeah, well, you know, if I had, oh man. Again. Send me some students who want to do this work. We have funding for them, and you know, I always had more money than students, so it's.
Oh, really?
Well, that is the good side about the applied work. So in sum total, Boeing's giving us $5 million. So they like what we did.
Where are you getting it from? Transportation?
We got it through Boeing, through the IRB program, the and Regional Benefits Program. It's the offset program. So I don't know, we're probably out of time. I don't know we want to talk about the Canadian Granting Initiative.
When someone gives you millions of dollars, you should learn the name of the...
We found this program. We went to Ottawa and met with the Director of Policy and Research for Prime Minister Harper, who turned bizarrely to be the ex-roommate of our development officer. And he said, go to this program and you know, you can, Boeing basically gets an offset for the sales of planes that they sold to Canada, and they get a nice multiplier for it. Now at this point people say, you know, well come on, they had to give you the money. Well, they have to give the money to somebody, but then so does the NSF. So there's still a competition, but Boeing is a very motivated giver in this case. This last, we kept 1.3 million, we put one into our institute, we put another one into this consortium to see that. And so we've actually given most of the money away. I can't spend that much money. I can spend about $250,000 a year tops.
We're going to have to talk about this then.
On that note.
No, sorry.